Uh-oh.
All right, and we're back downstairs working on the super tremolo, non-tremolo JTM 45 amp that Marshall never built. But maybe they did, maybe they didn't. But it's sort of like the amp that I wish that they built. So where we're up to right now is we just really need to stuff the parts in the board. Now, normally I would be telling you that it is brought to you by Three Monkeys Solderless, home of the world's best cables for your pedal board. So we got RCA, we got 1/4 inch, we got DC. This isn't for your pedal board, but this is for your turntable. So if you have a turntable or a car stereo, you need this. So this is the DC for your pedals, and that's the 1/4 inch. There's no wire stripping, there's no soldering. It's great. So normally I'd be doing this outside of the amplifier, but since this is kind of like a one-off design, I figured there'd be no point in making a jig for it to put out the wires and figure out the wire lengths. So what I'm going to do basically is just use my calipers, right? Which I've been, this is sort of like what I came up with like 25, 30 years ago, whatever, for figuring out, maybe more, how to, you know, just to make the wire bending to the right size quick and easy. So basically what I would do is, like, let's say for here to here, so we've got like a skip 2. So I've got a piece of the phenolic here, which is the same sort of like distance between the turrets, between the holes. So I would just measure out the skip 2 and I would go like end to end, right? And then that would give me the correct distance on the outside of this side of the caliper, right? This is sort of like the distance that we're measuring. And then this side shows us sort of like, gives us inside diameter, right? So outside, inside, but they're the same thing. So that would be assuming a wall thickness of 0, right? So for those of you that are into that sort of thing. So anyway, then I would just put this on the table and I would bend my resistor leads around it. So I'd put it over here on the side where you can't see it, which is perfect. And just start stuffing the components. And then I'm gonna move, I guess, across, and I'll usually like to work from the inside out, doing the shorter leads first and then doing the larger leaded components later. I'll do the bias area first, so we'll just start over there. So we're going to start off with our range resistor, right? So I have all my resistors all laid out on the side over here that I've pre-selected. So hopefully we can move through this with a minimum of disruptions of me looking for stuff. But I'm sure that's going to happen because, you know, last time I did this, I've had them all laid out neatly for the values that I wanted for each position, and then I went ahead and spilled them all on the floor. So that may not have been the best, you know, best video I've ever made. So let's go ahead and keep moving. So next we would be putting in our diode. So I have to find all these parts. So they're all over there, over on the side. I'm not going to show them all to you because that's how I ended up spilling them on the floor. Here I'm taking off on some of the components a little bit of the oxidation. And for this one, I'm just going to kind of do it by hand because I think it's just quicker, because this is a unique distance. So I'm just going to use my needle nose here, and I'm just going to bend them to length. I mean, you could do this too, all the way around the amp if you so desired. Save a little time with, you know, the caliper method. They do sell little gauges that will allow you to, you know, just bend on different areas. That just seemed like it didn't really ever work for me, so I didn't use that. I got to turn on my soldering iron over here to get that nice and hot so we can continue to solder, which is good. All right, so now we need a couple of 15K resistors for our range. I'm setting our range, right? So we're now over here. So I'm going to go ahead and, in this case, I'm going to use the caliper. So it's just a skip 1. So I'm going to take it about like that. Go ahead and bend them out. I think I told this story before about using the calipers for bending resistor leads. So there was one time, I don't know, this was probably like in 2000 and, I don't know, 4, 2005, something like that, 2006, I can't remember. But I was building some amplifiers for Green Day for their fly rig, and I went out to meet, I will bend this a different way. I went out to meet my business partner, or future business partner, I think at that time, Greg, who was working for the band, working for Jason, and I brought out an amp to tweak out there, and I brought my calipers with me, and I was like using them, and I remember they were looking at me like, why is he measuring the resistor lengths? And then they saw I was sort of like bending the leads with the calipers, and they were like, oh, okay, that makes sense. So it can be a little bit goofy in that regard. That's like, what are you doing? I get a lot of that in my life. Moving along, we're going to put in our capacitors. I think we're starting to get the soldering iron hot now, so we can actually first put in our adjustment potentiometer, our little trim pot in there, because that was sort of like a good time to go ahead and do that. So I have the trim pot here. It has 3 legs, right? The wiper and the 2 outside ends. And the way I kind of do it is to connect the wiper here, right, with the outside end here with some bus wire. Go ahead and cut that and chop it off. I'm gonna crimp it down a little bit there and there. I'm gonna get that out of the way, and then I'm gonna solder it in place. We're gonna have to order some more solder soon. This is kind of at the end of the line. We're nearing the end of the roll. So I'm just kind of joining these 2 legs together, which makes it, it's basically like a single variable resistor, no longer a voltage divider. So then this can go in here. All right, there we are. And then now is a good time to solder it so you don't end up burning anything that you don't want to burn or melt, like a capacitor. This would be sort of in your, the capacitor would be in your, well, we don't want to do that one yet, sorry. I almost messed myself up. Okay. Then we're going to put in our capacitors. So I got myself my pairs of Spragues here, my Adams, which is what I like to use. I think Sprague makes some very good capacitors. I've always liked using Spragues in these builds, and I'm just like, you know, removing a little bit of the oxidation off the leads and straightening them out with my needle noses. Needle nose Ned. Ned the head. Bent them to our appropriate length. There we go. And we can just go ahead and solder these guys in place. And your solder joints, when you're done with them, should look shiny, right? That you should be able to see reflections in there, like a look at yourself in the bulge of the solder blob. Turning on my fan. Hopefully that's not making too much of a racket, but I shouldn't be breathing this smoke. Got ourselves our pink drink to keep ourselves going. All right, so next we're using our dropping resistor, which is a 10K. So we'll grab our 10K resistors. Gonna use some metal film. I like metal film for these positions as they're nice and quiet. I think resistors, you know, they create different kinds of thermal noises, you know, and depending upon what they're made out of, they can either add noise or stay a little bit quiet. So I do like the metal films for these positions. Just going to pre-bend them. So we're going to need 2 of them, so I'm pre-bending 2 of them. Okay. And then pretty soon we're just going to start working on the shorter length resistors in groups. All right, so we'll do this one. We're going to do our feedback resistor as well. Now, on the JTM45, I prefer to use a 27K feedback resistor. So that gives you, you know, your feedback resistor has a lot to do with the way that the amplifier distorts. Like how much distortion is it going to create in the phase inverter. The job of the feedback is to basically inject signal that is out of phase with the phase inverter. And then as the signal output gets louder, it produces more signal to feed back to the phase inverter, which then balances it and pushes it down or dampens it, as you would say. So it's kind of a reactive, kind of live, a live situation where at one point, you know, it's doing less, and then at the next point it's doing more, depending upon how the amplifier is set. So it's sort of like a self-limiting kind of circuit, which is kind of interesting. And of course, it's at frequency as well, and your presence control and all of that will have a bearing as well on what frequencies will be fed into the network, because you're basically dealing with like a negative filter, right? So like a, you know, it's a sort of a whole new interesting type of tone stacks. So theoretically, you could take like the inverse of this, sort of like a Fender Orange Marshall or whatever you want to call it, tone stack, this type of tone stack, or Vox Orange Marshall, whatever you want to call it. And if you were to do it out of phase, you would be able to sort of make an active control. Like if you were using an out of phase feedback system coming from these controls back into a part of the amplifier, you would have like an active tone control in a sense, or you could possibly be able to boost frequencies or cut frequencies. So it's just interesting stuff when you're dealing with different kinds of feedback, positive and negative. Some stuff that's kind of overlooked sometimes. I mean, the Marshall majors, like the Pig, used to use kind of like that kind of a system. Some people thought that amplifier sounded like hell, but you know, that's up to them. All right, so let's continue on. We're going to do these guys right here, right, which would be right, one over and one up. So just basically from like here to here. goes up with the resistors. So we're going to do our bias splitters. Up at the top, I like to use a 220K here. Nothing too unusual there. So just prepping my resistors. Adding the leads. So we keep going here. Trim the leads. Hopefully we could get this all done in the allotted time we have today. I'm pretty sure it shouldn't take that long, but being that I'm kind of flapping my gums, everything always takes longer when you're doing things sort of on your own while you're talking. Just want to verify that this resistor was the one I selected for that position, and it is. Okay. I dropped my resistor. I think we talked about what kind of resistors I'm using. Some people are like of the opinion that you have to use carbon films in these. So the original resistors would have been carbon deposit resistors, I believe. And in terms of performance, I think to my mind, or my ear, my way of thinking, the closest to them would be these 1 watt carbon film resistors. So I started using those quite a while ago. I used to get them, which one is this? Okay. I used to get them from Radio Spares in England, but now I get them, I use a Royal Ohm resistor, which I like very much. All right, so we got these in, now we can just solder their junction here, because that's harder to get to once the all the rest of the components are laid in around these resistors, right? The phase inverters, resistors, the bias splitter, the plate resistors. All right, now we can, actually we could do, this one is the same length as this, so we could stuff in our 100K plate resistor there. So this is the left. Okay, yeah, that's the right. All right. I mean, all right, so in terms of like blueprinting an amplifier and selecting your resistors for this stuff, it's not, there's no dark art here. All right, I mean, there's such a thing as stacked tolerance, which is when, let's say all of your resistors, these are gold resistors, so they're, 1%, 2%, whatever, I can't remember, 1% resistors. So they're on 100K, you're going to get a 1K variance. If you were to put 100 of these resistors in series, right, to make a 1 meg, or or you put 10 of them in series to make a 1 meg resistor, you would have the stack tolerance of each 1% of 1K, so you'd be out by possibly 10K at the end of it. So parallel resistance, series resistance, as you go through the circuit, the variables do add up, right? So you get like a larger tolerance through stacking of tolerances of the components that make up the circuit that you're using. So it's a good idea to check that your resistors are within what you want them to be. So when I'm blueprinting an amp, when I say that these are specially selected resistors, so to speak, it's not that I'm like, you need a 99.8K resistor here. Because first of all, you're dealing with temperature variation, you're dealing with all kinds of things, and to get that crazy is nuts. and I don't think there's a human alive that would be able to hear the difference between a flat 100K on the nut or a 99.8K resistor. I just don't see it. So the purpose of blueprinting the amplifier is kind of to make sure that all of the things that you're doing, you know, are all your components are within spec. That you're not putting something in there that's a, you know, an aberration of manufacturing that causes your amplifier to sound bizarre, and then you have no idea why it sounds that way because this resistor was out by 10% or what have you, and you're like, this amp is a dud. So the point is, there's no, in my mind, there's no magical numbers. Get the number that you're looking for and make sure it's not outside of the sort of normal production sort of variances. So that's enough of that nonsense. So let's continue on. I'm going to put in the rest of the stuff that's generally that size. So we're going to need some 68Ks. Where did I put my 68Ks? Did I put them over there? See, I told you this was going to happen. They're around here somewhere. I had to order some more as well. Let me see what I did. Where did I put them? All right, here they are. It's kind of, the last place you look is where they should be, right? You get kind of panicked, and then you're like, where are they? And they're right under your nose. So yesterday I was ordering a bunch more resistors for builds in different values, and that kind of made me think that, did I put the resistors that I selected somewhere else? Or did I not select them because I had the bags out and I was, you know, using the part numbers off them? I don't know. But I did my job correctly, which is probably why I screwed it up. I usually don't do things right. Here we go. I guess I could talk about what these things do, right? For people who are like, what's all that crap in there? So these are 68K resistors, right? And these resistors come from the input and go to the first preamp tube. And their purpose is a few-fold. They're a grid stopper, whereas large signals will meet this resistor, which is a current limiter in a sense too. So it will help the tube cope with large signals that are smashing into it to an extent. It's also used as a load for the first preamp tube, being that in certain situations, let's say when you're in the low input on an amplifier like this, right? There's a high and low input. There we go. The low input will have one of these 68Ks going to ground, which will then give you a path for the signal to go to ground that would be 68K. If you're going through the high input, these two are in parallel, which would give you, what, 34K resistance going to the ground, going to the tube instead of 68K, as well as there's no direct path to ground except through the 1 meg resistor that's on the pot. So then you would have a very high impedance sort of situation, which would allow most of your guitar signal to reach that first preamp tube. So the purpose of these resistors is basically to set the impedance, or help part of the formula that sets the impedance for the first preamp stage, giving ground reference, giving the load, all of these good things. All right, so we can go ahead and solder these guys in. So some amplifiers will use, a lower value resistor. Why did that get stuck? That's interesting. get back in there. There we go. All right, what was I saying? Oh yeah, so some amplifiers will use a single resistor if there's no high and low input switching. And a lot of those would have been like Marshall derived sort of clones. So they'll use like a 33K because that's sort of like the most commonly available resistor that approximates the 34K. Some like Jose amplifiers didn't even use a grid stopper on the first stage. So you have all different kinds of like theories about what more pink drink, what would sound better. All right, so let's continue on. We can take care of our mixer resistors. Grab those. Other one's over here. All right, so these are the two resistors that I selected for the mixers. So these are the resistors that combine the two channels to go into the tone stack. Right, so they come off the volume pots. Right, so you have your first tube sort of connected by capacitors to the volume pots. The volume pots will throw out whatever signal you choose to throw out by the adjustment of the potentiometer. They will then meet here at this junction of these two 220K resistors, and they will then go into the cathode follower, which has the tone stack, right? The bass, middle, and treble. So this little area here will set a couple of things, right? And so if you have one of the volume pots turned all the way off, you will have a ground reference of at the junction of 220K, right? So if this volume pot's turned all the way down to 0, you get a dead short from this end of the 220K resistor to ground. So this is the channel that you're in. It'll go through the 220K. Part of the signal will go off to ground, and then it will continue on to the rest of the amplifier through the tone stack, through the cathode follower. So that's why turning up this knob, even if you're not plugged into either one of these inputs, will give you a higher signal as this ground reference now goes up, right? And when it's fully clockwise, turned all the way on, you'll have a 1.2 meg reference to ground, being that this is a 1 meg pot. So that's why you're going to notice a change in your sound when you crank up that second volume. Now it also will set a sort of it's sort of a peak filter, a peaking, we would call that. So it's a bypass. And you're on the bright channel, you use a capacitor, right? And I'm using a 250 picofarad mica capacitor to bypass this 220K. And then you can use the math formulas, 2 pi RC to figure out what the band pass is for that particular combination of a 220K with a 500 or 250 PF, 220K reference to ground. So that creates a filter, right? That is an actual filter. So this adjustment will also affect what your filter sounds like as well. And, changing out that value of that capacitor, the 250 PF, for a larger value, will move the center frequency of the bandpass in a direction, right? It'll move it, let's say, more towards the bass side, right? It'll give you a little bit more signal. It'll give you a little bit more mid-range, or you can change the value of the resistor, right? So a 220K resistor bypassed by a 250 picofarad capacitor will sound different than a 1 meg resistor bypassed by a 250 PF capacitor. right? So you'll have a much more pronounced treble peak with the 1 meg 250 as you would versus the 220 250 picofarad. So hopefully that makes sense, right? It's pretty logical and intuitive. You don't necessarily need math to figure that out, right? It sort of makes sense in your head. Where else are we going? Oh, we got to put in our long tail on our long tail pair. So we need our 10K resistor. All right, we got our 10K going. So all of this is network here is basically a combination of setting the bias of this phase inverter tube, right? The 10K, the 470 ohm, and your 5K presence pot, right? All determines the bias point of the phase inverter tube. Now, the other purpose of the phase inverter tube is to create two signals, right? To flip the phase, flip the phase of one of the signals that will then be used 50% of the time in the duty cycle of the power amp. So one side will be out of phase from the other side. They'll each be fed individually to their power tubes, and the transformer will be using them 50-50 in the positive and the negative of the duty cycle of the sine wave, right below the center line of 0 and above the center line of 0. Each side will take its own sort of signal from the phase inverter's flip. Now, every phase inverter, you can argue which are better, which are worse, you know, that they're not perfectly balanced. But asymmetry in a phase inverter, which, you know, a Marshall does have some asymmetry. It's not as bad as, let's say, like a cathode in a Fender, but it does have some asymmetry. And in my mind, asymmetry always sounds better than symmetry. It just seems to. Like, so if you're doing clipping circuits, I always find that, you know, asymmetrical clipping circuits sound better than symmetrical clipping circuits. Now that's me, and if you don't think that's the case, then it ain't, right? Because this is all taste. There is no, you know, I can't. It's escaping me right now. But there is a Latin for that. Like, among taste, there is no dispute, and I used to hear that all the time at home. Gusto disputitum. I can't remember what it is. I'm ashamed, actually, because I used to hear that every day. So in taste, there is no dispute, is basically what it comes down to. All right, let's continue on. I'm going to get my... Where did I put those? Yeah. Okay. Sorry for the delay. I have to read the color codes, and I was not sure in the pile which were the 1 megs. It took me a second. Kind of, to me, looked like I might have, I don't know. My brain was telling me that these were 150 Ks for some reason. All right, so let's continue on. All right, we have to remeasure. Did we remeasure? We did remeasure. All right, so we don't have to worry about that. So I'm going to bend my resistors. Okay, these are ready. So these are our 1 megs. I got to get the 470 ohm resistor out of the pile. There we go. Now we'll get a 470 ohm. How are we doing on time? 35, somewhere around there. So I think we'll finish. I should probably shut up. That might help. So we're going to go ahead and bend this one by hand. There we go. So I like to kind of bend them a little bit so that there's room for them. So if you bend them all so the resistor bodies are up higher, they kind of bump into each other, which annoys me. It may not annoy you. So I'll bend them a little closer towards this side so the bodies of the resistor have a little bit of room. You know, it makes it more funner for them. Resistors don't like to be crowded. They're very individual type things. They enjoy just being by themselves sometimes, or having enough space to move around. All right, so I'm going to put in this other plate resistor. I'll just do this one by hand. There's no sense in spending a lot of time setting that up, although the way I'm doing it probably wouldn't have mattered. Shaky the clown over here. Okay, so those are our plate resistors. All right, now we need to put on our slope resistor, which I use at 56K. There you go. There's our 56K. All right, now next we can put in all of the leads, or all of the resistors now that go basically full length. There's no longer any smaller length or shorter length resistors, so now we can set our little gauge here for full length. All right, so from there to there. Can always, my ear always perks up when it's either Mozart, Schubert. I don't know what it is about them. All right, so what am I doing again? I'm working. All right, so now we need to put in our different resistors everywhere. So actually, let's start over on this end. So we'll do, it's a shared cathode, which uses an 820 ohm bypass with a like a 330, but I use a 250 mic capacitor. So I've got my capacitors here. All right, I'm gonna grab 820 ohm I've got for it. So here's our capacitor, right? We're using the Spragues again, the 250s. And we're going to put in our capacitor. So I'm going to put a little pre-bend on it. And then I'm going to bend it once it's got the pre-bend on bent. So that'll give me a little bit of room there, see, for our resistor. I don't know why this resistor wants to stay all the way over on this side for some reason, but it does. And we're not having it. There we go. So I like that look. So we can just start soldering. This one's done. Pink drink. All right, so now we're going to put on our coupling capacitors. Clean these guys off good because these have probably been sitting for the better part of 50 years. Put our bend on them. So the customer also sent me some tubes for this thing. So that's going to be pretty fun when we get to pull those out. Also got a pair of original silver bell Alnicos. Where's the line on that? There it is. Okay. To go in the cabinet. So if this is like the first time that you've tuned into the build here, there was a orphaned Style 2 6768 Bluesbreaker 212 combo cabinet with the Clapton pinstripe cloth on it. That was that he picked up, and then it kind of, we ran into what we would call in the business mission creep, where it was going Bluesbreaker cabinet. All right, I'll see you Bluesbreaker cabinet, and I'll add in Style 1 chassis into and circuit into that, and then it's like, okay, where are we going from there? Oh, I'm going to get an NOS Mazda, you know, which is basically a Mullard GZ34 rectifier tube. I'm like, all right, we're going to get mustard capacitors for it. And then it's like, all right, then we're going to get Genel X KT66s for it. And it's like, all right, then we're going to get, you know, Mullard preamp tubes for it. And then the next thing you know, it's got, you know, just dead mint silver bells in the thing. So this project is like just gone to the moon pretty quick. But the result, I think, is going to be, I think it's going to be crazy. I think it's going to be stunning. So this is what it's all about, right? Is kind of making something that's really cool. So it was like someone left, you know, all these pieces of gold everywhere, and you're just assembling them and putting them into something and making something out of it, you know? So it's like putting in all these different kinds of parts, you know, in tubes and speakers and cabinet. It just makes sense. I mean, you know, maybe we could find an original Style 1 chassis somewhere, but we haven't. So this is sort of like where the restoration's coming from. And we get the chance to build the amplifier that Marshall never built. So how good is that? All right, let's continue. All right, so we're going to do the cathode for the cathode, for the cathode follower over here. So that's comprised of 100K and an 820 ohm resistor. So I've got my resistors that I've selected for the positions ready to go. Just gonna drop them on the floor again and then continue. Come on, let's get some Mozart. Do, 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 do. Nope. We did not win the Mozart lottery this time. Let's see if that'll spread. Yeah, okay, that's good. And our 100K. Now we're going to put in our treble capacitor. Which again is going to be a silver mica, right? Silver mica 250 puff, the Magic Dragon. So these again sort of decide the high frequency response or part of it of the amplifier. 250 puff would be the JTM 45 kind of value, which would have been, you know, derived from the 5F6A Bassman, the Fender amp, which basically is what this is. It was sort of like Jim Marshall. I think the story goes that, you know, you couldn't really get Fenders in the UK at the time, and so Jim Marshall was like, well, why don't we make our own? So he got Ken Brand, who was his solder jockey, as we like to call him, to go and start raiding for spare radio parts from, of all places, radio spares, to start making these clones of 5F6A Bassmans, but with UK parts and a UK sort of like design. Now, you know, granted, Jim Marshall came up with, you know, a lot of cool things, for sure, that made Marshall Marshall and Fender Fender. And so there's no taking away from that. But yeah, I mean, these are basically 5F6A Bassmans. Some more capacitors. Clean them off good. Now do you... Oh, wait. Okay. So I'm going to do the second bend just by hand. I'm really shocked I haven't banged the phone yet with my head and dropped it on the table. This one's being squirrely. There we go. Still being a little squirrely. So I can put those in there and give this a little torque up. And there we go. All right, so for soldering, hot soldering iron, get in, get out quick. All right, don't spend all day in there heating everything up to the extreme. All right, so there we go for there. Now we're putting in our dropping resistor and our, whatchamacallit, filter capacitor. You know what, we should put this one in first. So we'll put in our last little guy here. All right, we could solder this together. We had our other 10K already sort of pre-bent. I knew I forgot something. I forgot to put the ground on that the other day when we were working. Not a problem. We can just do that right now. Where are my wire strippers? There we go. Get that out of there. Nice. Can't believe I forgot to do that. See, that's what happens when you're trying to talk and make a video while you're actually working. So we can bring this up. Okay. Okay. Are we under everything? No, we are not. Here we go. Now we should be under everything. Just got to sneak it back over this way. There we go. Now we're good. Put a little bend on there. Get it up from underneath. Come on, guy, get in there. Make the room for it to come through. There we go. Bend it around. Gotta scoot these wires out of the way a little bit. There we go. Okay. We could go ahead and solder that in place. Nice. Then we could tuck it back to where it needs to be and clean up the rest of this. That's good. All right. So we're in business again. All right, so let's go back to stuffing the board. So we got our 10K in there. There we go. Now let me get my good filter capacitor. So we're using a single 16 here, which really gives the amplifier a really kind of cool loose feel, a nice top end to it. The bottom is nice and spongy. You know, it gets really JTM 45-y, if that's a word. And you know, with these amplifiers, a lot of people are like, well, you know, you need to turn the, didn't sound. You need a flubby amp to start with if you're going to do all like the Clapton stuff and all those kind of like vintage things. First of all, the clean sound from this amplifier is going to, with this kind of a filtration setup, is going to far exceed one that's a little bit more heavily filtered through the preamp and through the power amp. But more importantly, too, the lead sounds when you get the right gear going through this, right? So you're going to want to use something like a treble booster on it. And then you can start benefiting from this amplifier's bass response. You still may turn down the bass control a little bit, but you're going to benefit from the increased bass response of the amp. So it's all part of the thing, right? Like if you use the treble booster with a 72 super lead, I mean, you can do that, but it's not going to sound the same as using a treble booster with something like a 63 JTM 45, which this is fairly close to. All right, continue. So every amplifier kind of has its own thing. Right, and this is also part of it over here. Let's move that over. Now, sometimes I've often debated about this, right? And I do think that I still land on using the 0.1s for JTM 45s, but I have built them with 0.05s, which are kind of interesting as well. They're kind of like a happy medium between using like the 0.02s that you would see in like a, you know, the beginnings of the 50s sort of like deals, you know, like the JTMs, Black Flags, or moving into what would become, you know, the 1987s. Get in there. Why are you being so mean? There we go. We're going to leave that side open, obviously, because we still have to put in that 47 Pico snubber in there. There we go. All right, let me get the 47. Where did I put it? Right here. We got ourselves a little 47 puff silver mic for this position. Now the last capacitor is for presence control, which we're using the 0.1 as well on the presence control. So basically that just goes here. So we can feed this up. Get that about like that. There we have it. Nice. All right, so the last things to do, and then I think we're done with all the wiring, is to screen supply, and then, well, the camera ran out of memory. So I think we got basically everything that we needed to finish the wiring of the amplifier. So all that's left to do at this point is to mount the chassis. We'll bias it up and all that stuff, put in the tubes, bias it up, and then mount it in the cabinet, and then give it a test ride. So once again, thanks for watching, and we'll see you next time.